In this video, you will learn about forms of rational numbers. Now we have what we call rational numbers, and we also have what are called irrational numbers. Rational numbers is anything that can be expressed as a ratio or a fraction. So for example, 3 over 4 is rational because that can be written as a fraction, and it is a fraction. 4 over 3 is also rational because it is expressed as a fraction. Negative 3 over 4 would be rational because, once again, it can be expressed as a fraction. Decimals would also be rational, so like 0.75. That is rational because I could write that as 3 over 4, which is a ratio or fraction. 4.75 would also be rational because I can write that as 4 3/4, or 19 over 4. So that is rational because you can write as a fraction. 4 would also be rational because that is the same thing as 4 over 1, which is a fraction. Even here we have 0.3 repeating, so this decimal keeps going forever and ever and ever. It's 0.33333, etc. This can be written as a fraction as well. This would actually be 1 over 3, or 1/3. So that would also be rational. Irrational numbers are numbers that cannot be expressed as a fraction. For example, pi would be irrational. Pi is a number used in geometry, and this is equal to approximately 3.14159. But the decimal keeps going forever. It never ends. So pi is irrational because the decimal keeps going and does not repeat. The square root of 17 would be irrational. So it's not a perfect square. I cannot take the square root of 17 and get a whole number back out. So that would be irrational. If it was a square root of 16, the square root of 16 is 4, which would be rational, so that would be fine. But if it's not a perfect square, then it would be irrational. Here we have 0.12, 122, 1222, 12222, etc. So this one does have a pattern. You keep adding one more 2 each time, but that doesn't mean that it's rational. All right, this would be irrational because it keeps going forever and nothing repeats. The 0.3 repeating over here, that would be rational because this is a repeating decimal. So if it's repeating, even though it goes forever, it's still rational. If it's not repeating and it goes forever, it would be irrational. Now with rational numbers, we are going to perform different operations with them. So to begin with, we want to know how to simplify rational numbers. So to simplify, we would say that a rational fraction a over b is simplified, or in lowest terms, if the greatest common factor of a and b is 1. For example, let's say we had 8 over 28. Okay, right now the greatest common factor between these two is not 1. All right, it's going to be 4. So I can divide the top and the bottom by 4, and that would give me a 2 on the top and a 7 on the bottom. So if I simplify, I now have 2 over 7. So it's the same thing as reducing. It's just a different term given to it. So this is 2 over 7, and this is in simplest form. This is in lowest terms because the greatest common factor of 2 and 7 would just be 1. We cannot divide anything else into 2 or 7. Example 2, we have 30 divided by 35. To simplify, I figure out what is the greatest common factor of 30 and 35. What is the largest number that I can divide both by? And that's going to be 5. I can divide both by 5 to get 6 on the top and 7 on the bottom. So this is how I simplify a fraction. I can divide the top and the bottom by the largest common factor. And now notice 6 and 7 cannot be divided any further. the greatest common factor of 6 and 7 at this point would just be 1. So this would be in simplest form. Next we have proper fractions versus improper fractions. So what is a proper fraction? Well, a proper fraction is when the numerator is less than the denominator. So remember, the numerator is the top, denominator is the bottom. So for example, 2 over 3. The top is smaller than the bottom. The numerator is less than the denominator. So this would be a proper fraction. An improper fraction is when the numerator is greater than or equal to the denominator. So for example, 3 over 2. The top is bigger than the bottom. So this would be improper. All right. So with fractions, we also have what is called mixed numbers. A mixed number, by definition, is a combination of a whole number and a fraction. So for example, a mixed number would be 1 and 1/2. All right. I could write the mixed number as an improper fraction, which is 3 over 2. So we have mixed numbers versus improper fractions. So this is improper once again because the top is bigger than the bottom. So these two are the same thing. Okay, there's two different ways of writing the same fraction. Now the objective in the next slide is to convert between improper fractions to mixed numbers. So if you were given an improper fraction of 14 over 5, how would I write this as a mixed number? So all I do is I divide 14 by 5. So we should know how to divide at this point. We have 14 divided by 5 and 14 divided by 5. We see how many times is 5 going to 14 evenly, and that's going to be 2. So it goes 2 times evenly into 14. And then I multiply 2 times 5 to get 10. And then I subtract 14 minus 10 to get 4. All right, so I have 2, and then 4 is my remainder. I write the remainder of 4 as a fraction. I take 4 over the 5 over here. So this is going to be 2 and 4 over 5, or 2 and 4/5. Example 2, let's say we had 43 divided by 6. So to write this as a mixed number, I divide the two numbers. So I see that 6 goes into 43 7 times. So I multiply 7 times 6 to get 42, subtract, and I get 1 as my remainder. So the 1 I write as a fraction. I write it as 1 over the 6. So my answer is 7 and then 1 over 6, which would equal 7 and 1/6. So this is converting from improper fractions over to mixed numbers. Next, you need to know how to convert from mixed numbers over to improper fractions. So let's say you had 1 and 1/3. So there's two ways to do this. I'll show you a longer way and then a shortcut way. So the long way to convert to an improper fraction is I take the number part, so the whole number, 1, and write that as a fraction with the same denominator as the fraction part. So write this 1 as something over 3. Well, 1 would be 3 over 3, right? Because 3 divided by 3 is 1. So I have 3 over 3 plus the 1 over 3. So with fractions, if I'm adding, the denominator stays the same, the numerators combine. So I have 3 plus 1 on the top is 4, and then 3 on the bottom. So my improper fraction would be 4 over 3. All right, so that's the long way. Let me show you another one with the long way. Here we have 5 and then 3 over 4. So 5 and 3/4. So I take the whole number of 5 and write that as something over 4. Well, that's going to be the same thing as 20 over 4, because 20 divided by 4 is 5. So then I can add the numerators, 20 plus 3, to get 23, and the denominator would be 4. So that is the longer way to convert from a mixed number to an improper fraction. So the shortcut way, using the same numbers, 1 1/3 and 5 3/4, what I do is I take the number, so I start with the 1, multiply it by 3, this bottom part, and then add the numerator. So 1 times 3 plus 1. So 1 times 3 plus 1 is your numerator, and then your denominator would stay as 3. So 1 times 3 plus 1 is 4, so that's going to be 4 over 3. Alright, again with 5 3/4. I take 5 times 4 plus 3 for the numerator, and then your denominator would stay the same, and that would be 4. So my numerator, I have 5 times 4 is 20, plus 3 is 23, and that's divided by 4. Here's one more with a new number. Here we have 6 7/8. So to convert this one, I take 6 times 8 plus 7, and then put that over 8. So 6 times 8 is 48. 48 plus 7 is 55. Put that over 8. That's going to be 55 over 8. Now we're going to add one more dimension to this concept of fractions. So here we are going to now evaluate fractional expressions. So the only thing different here is we are needing to plug in numbers first into a fraction. For example, we have 4x over 2y. So here we need to first plug in a 3 and a 4. So evaluating means you're going to plug numbers in, and then you can simplify. So evaluate this expression when x is 3 and y is 4. So instead of 4 times x, I have 4 times 3. And instead of 2 times y, I have 2 times 4. So now I can simplify. I have 12 over 8, and I can reduce, and I do that by dividing the top and the bottom by 4. Divide 12 by 4, I get 3. 8 divided by 4 would be 2. So my answer is 3 over 2, and I can write this as a mixed number by taking 3 divided by 2. 3 divided by 2, I have 1. So 2 can go into 3 one time. Then I multiply 1 times 2 to get 2. Subtract gives me 1. So my remainder is 1. I can write as a fraction. I take 1 over the 2. So 1 and 1 half. So 3 over 2 can be written as 1 and 1 half. So notice the only thing different is plugging in the numbers first, and then I can get my fraction and then write as a mixed number or whatever type of number you are asked to write it as. One more example, you have to evaluate y squared over x plus y when x is equal to 3 and y is equal to 4. So here, instead of y squared, we have 4 squared, and then divided by x, we now have divided by 3. And instead of plus y, we have, this should be plus 4, not 3, plus 4. Alright, so we have this expression. So we can simplify. 4 squared is 16, and then 16 over 3, and then plus 4. Now we want to combine this, and to do that I need a common denominator. So the 4 I need to write as something over 3, and that's going to be 12, because 12 over 3 is 4. Now I can combine into one fraction. 16 plus 12 is 28, and the bottom is going to be 3. I can write this as a mixed number by dividing 28 by 3. 28 divided by 3, I have 9 up here, because 3 goes 9 times into 27. Then I multiply 9 times 3, then subtract to get 1. So the remainder is 1. I write that as a fraction, so that can be 1 over 3. So as a mixed number, my solution would be 9 and 1/3. And that concludes our lesson for today. We will see you next time.